All right, now looking at problem 13, determine if the graph demonstrates direct variation. If so, find the constant rate of change. Well, we have two qualifications for direct variation. One is that it goes through the origin, and this graph does appear to go through the origin. And the second is that it's a straight line, and again, this graph appears to be a straight line. So since it has direct variation, we can find the constant of change. Remember, constant of change is k equals y over x. So all I need to do is find a point in which this graph intersects a coordinate pair. Well, that looks like a good spot right there. Its y value is 2. Its x value is 1. So my k equals 2. And then we plug it into our equation. Y equals kx. So y equals, well, we just said the value of k was 2, x. That would be the equation of our line for the line given. That does demonstrate direct variation. Number 14. Again, we need to check for direct variation first. I have a straight line, and it does go through the origin. So I need to find a point on this line where it seems to intersect a perfect grid line. Well, that seems to be way out here because, well, that's halfway between, or somewhat close to halfway. That's not quite there. That's not quite there. That's, again, close to halfway. And then that one finally does appear to intersect. So, again, k equals y over x. My y value is up 2. My x value is all the way over here at 5. So my k equals 2/5. And now, since it does show direct variation and we identified our constant and change, we can write an equation. Y equals 2/5 x. And you're getting the equation as a bonus because I just realized the question asked for the constant rate of change. Well, that constant rate of change was the k value. So our true answer was up here, k equals 2/5. But we can use that to form an equation that will be a beneficial thing for us as you progress through this unit. Number 15 says to dilate each figure by the given scale factor. And we have a shape that is a triangle. We know from class that we can't identify the length of that distance between AC, at least not at this point, because we have not used a formula that gives us that solution. So I have to dilate based on my coordinate pairs. So I first need to find the coordinate pair for my point A. So I would start at the origin and move backwards 1, 2, 3. Well, that's going to have an x of 3. Sorry, negative 3. 1, 2, 3, 4. It's going to have a y of 4. Now let's find my coordinate pair for B. Again, that's at that same point of negative 3. Negative 1, 2. Well, C doesn't move left or right at all, so that's just going to be an x value of 0. But it does move down 2, so a y value of negative 2. And now that I have found all of my original points, now I can do my scale factor, A prime, B prime, C prime. And scale factor, as we discussed in class, simply takes each one of these values and multiplies it by the scale factor. So negative 3 times 1/2. Negative 3 times 1 is negative 3. 2 times 1 is 2. So negative 3 over 2 would be the x value. 4 times 1/2. Well, that's 2. Again, negative 3 times 1/2 will be negative 3/2. Negative 2 times 1/2 would give me negative 2 over 2, which would be negative 1. 0 times anything is 0, so that should be a really easy one. And then negative 2 we already figured was negative 1. Now that I have a new set of ordered pairs with primes next to each of them, I know my dilated figure would be represented by the prime values. So I would graph them on the line. Negative 3 over 2 is negative 1.5. So negative 1.5 up 2. That's the value of my A prime, and I want to remember to graph that and label it on my graph. Next is negative 3 halves, negative 1. So again, negative 1.5, negative 1. That would be my value of B prime. 0, negative 1. 0, negative 1. That would be the value of my C prime. And once I've gotten each of my ordered pairs graphed, I simply connect the dots to finalize my solution for a dilated figure with a scale factor of 1/2. Number 16, same process, so GATE. Need to identify each ordered pair. Well, this one I come over 2 from the origin, up 1. Let's start at G, sorry. I'm going to move backwards 1, up 1, so that would be an X, a negative 1, a Y, a positive 1. A, we move forward 2, up 1. T, I move forward 1, down 1. E, I move backwards 2, down 1. And now we simply dilate by our scale factor of 2. So G prime, A prime, T prime, E prime. G value, X value is negative 1. Negative 1 times 2 is negative 2. 1 times 2 is 2. So I can graph negative 2 up 2. That would be my G prime. A, I have an X value of 2, so 2 times 2 is 4. 1 times 2 is 2. Well, now I can graph that one. 2, 3, 4, up 2. T, I have a 1 times 2 is 2. Negative 1 times 2 is negative 2. Now I can graph that one. 2, negative 2. E, negative 2 times 2 is negative 4. 1 times 2 is 2. So negative 4 and negative 2. Helps if you keep your negative signs. Thank you. Connect the dots and we end up with a dilation with a scale factor of 2.